Hello everyone. This is a continuation of our series on learning pandas for use in data analysis. Now we are starting this book on practical statistics for data scientists. We will go through each chapter, learn new skills, and review the ones we have learned from the previous book by Matt Harrison. Data comes from many sources: sensor measurements, images, texts, and videos. A Google search shows 2.5 quintillion bytes of data are generated every day globally. It's a lot of data. A major challenge of data science is therefore to harness the torrent of raw data into actionable information. EDA is essentially a type of storytelling for statisticians. Its primary aim is to uncover underlying patterns, grasp the dataset structure, and identify any potential anomalies or relationships between variables. Data can be unstructured or structured. Unstructured data is often processed and manipulated into a structured form. The structured data can be classified into numeric and categorical data. Numeric data can then be further classified into continuous, such as wind speed or time duration, or discrete, such as the count of the occurrence of an event. Categorical data can be nominal or ordinal. In ordinal data, categories are ordered. For example, if there is a numerical rating, say 1 to 5, where 5 is high and 1 is low. The typical frame of reference for an analysis in data science is a rectangular data object, like a spreadsheet or a database table. The rows of this 2D matrix represent records, cases, or samples, whereas columns represent features or variables. In Pandas, the 2D data structure is known as data frame. Let's look at an example dataset from Kaggle, which is about anxiety attack, factors, symptoms, and severity. Here we have categorical features such as gender, occupation, smoking, and recent major life event. And we have numeric data in columns such as age, sleep hours, and therapy sessions per month. We can further classify some columns into nominal data where there is no ordering, such as gender, occupation, and smoking columns. And we can also classify some columns into ordinal data, such as diet quality and severity of anxiety attack, where we see a rating scale. Here, diet quality is ordinal because it represents a ranked scale, even though it is also discrete. In numeric data, we can classify some columns as discrete, such as therapy session per month. And similarly, some columns contain continuous values such as sleep hours and physical activity hours per week. A basic step in exploring your data is getting a typical value for each feature variable, which is an estimate of where most of the data is located, and it is also known as the central tendency. There are numerous estimates that measure the central tendency of the data. I have covered these in detail in these videos, so please watch these and the previous videos on Learning Panda series for relevant material. An outlier is a data value that is very different from most of the data. Sometimes we remove these outliers, and sometimes these provide useful information. For example, these are the points of interest in anomaly detection problems. A second dimension, which is variability, is also referred to as dispersion. It measures whether the data values are tightly clustered or spread out. Again, there are numerous estimates to measure dispersion or variability in the data, and I have also covered these in detail in these videos, so please watch these and the previous videos on Learning Panda series for relevant material. Data visualization is an important component of EDA because it allows a data analyst to look at their data and get to know the variables and relationships between them. Box plots and histograms provide useful visual representations to explore data distributions. A histogram is a way to visualize a frequency table with bins on the x-axis and the data count on the y-axis. A density plot can be thought of as a smooth histogram, although it is typically computed directly from the data through a kernel density estimate. Bar charts are a common visual tool for displaying a single categorical variable. Pie charts, on the other hand, display the frequency or proportion for each category plotted as wedges in a pie. EDA in many modeling projects involves examining correlation among predictors and between predictors and a target variable. The standard way to visualize the relationship between two measured data variables is with a scatter plot. More useful metric for correlation is a standardized variant, the correlation coefficient. This gives an estimate of the correlation between two variables that always lies on the same scale. Its values vary from -1 to +1, where -1 indicates negative correlation and +1 indicates positive correlation. A correlation coefficient of 0 indicates no correlation between the two variables. One thing to note here is that, like the mean and standard deviation, the correlation coefficient is also sensitive to outliers in the data. There are additional plots that we can use to explore two or more variables. For example, contingency tables provide a tally of counts between two or more categorical variables. Other types of charts used to show the relationship between two numeric variables include heat maps, hexagonal binning, and contour plots. Heat map data visualization is a powerful tool used to represent numerical data graphically, where values are depicted using colors. These allow for quick identification of patterns, trends, and correlations within datasets. Okay, this is all I wanted to share in this video. Please keep watching as I'll show a project example of EDA in the next video. Don't forget to subscribe to my channel and like and share this video. Thanks for watching.